Welcome to today's video, guys. So we're gonna be working on the Hellcat swapped Dodge Dakota, and we're gonna be digging into our driveline angles, double checking that. I picked up a angle indicator, so we've got one of these that as you tilt it, it shows the angle. I also have the truck on the ground, having a little bit of issue getting the rear axle fully loaded since this is a two-post lift. I ended up putting it on a set of these, you know, move around cart things. I don't know what the official name is for it, but you can put a vehicle on it and kind of, you know, move a vehicle around the floor. So I have those dollies on it, and on the back I have the rear axle supported under its own weight. So this is our new ride height, maybe a little bit lower, but pretty much it. Supported. We've got some safety stand under there. Like I said, ideally, if you had like a four-post lift and you had the whole thing driven right up onto it, it would be a little bit easier, but I'm trying to manage to load the suspension. I tried putting jack stands under the front, but I couldn't get it to load the rear axle properly. So this way I did with having these, you know, dollies under the front. It was able to kind of pivot down as I, you know, put the weight of the vehicle down. Regardless though, I'm gonna sneak under there and we're gonna check our angles. So even though the truck is on a different angle, everything's gonna be relative. So we're gonna use our different numbers and we're gonna calculate the differences between each one based on whatever it is. So it's all relative, you guys. So as long as we have a certain degree between each one and our pinion is close to our actual transmission angle, then we should be pretty close. I'm also going to go down to John's Drivelines probably on Monday, get them to double triple check it, maybe dial it in a bit better, but I just want to get a rough idea with this. So let's go underneath there and see what we got. So I'm literally jammed under here with everything about an inch off my face. It's good times. But you can see here, so this is our first surface. This is where it meets the transmission. So we want to measure the angle of the tail shaft of the transmission. So there's two flat surfaces I have. It's this one. I have the vehicle in neutral so I can kind of rotate it around. I have this so that it's square. So this is actually at 0 degrees running this direction. And I also have this here, but I can't quite get my angle meter on here. So what I'm doing is putting a flat stock piece of steel and double checking that this is parallel with this so we can get this. So again, it's all relative because, you know, since the vehicle is not perfectly level as well, we just want to make sure that it's relative to the actual chassis on the truck. So like I said, I'm getting about 1.5 degrees from here to here. Take my word on it, I can't really get the camera in here and myself and hold everything at the same time, but that's what we got right now. Okay, so hopefully you guys can see there, it's about 1.5 give or take. And then we move on to the actual drive shaft. And we are at pretty much like 1/2 degree, I would say. So this is like 1 degree down. Okay, and last but not least, we've got this squared. And you'll see we're about 2.8. Another way to double check is off of the crank pulley. So we're pretty much 1.5 right here as far as our degrees, and this is all relative to as long as you don't change it or like zero it out, it's all relative. So it's pretty much the same as what we got off the transmission side. We got John Squad, John, Chris. Now they're wearing the correct shirts this time. So check this out, you guys. So this is like that. So I got 1.5 here. We verified it from the crank, and again, this is all relative since the truck is, you know, jacked up and stuff. But so you're looking for the difference between the angles. So 1.5, 0.5 down, and then 2.8 up. So we need to take that 4 degree shim out, and that should put us, if you know, 2.8. If we get rid of 3 degrees there, and then go the opposite direction, that should put us within 1/2 degree of our transmission. So I think we're gonna just completely remove the shim, and then we'll check it out after that. All right, both 4 degree shims are out. We're sitting flat on the axle now, no shims. Before they were in here like that, and now they're out. So let's see what we got. All right, so we're under here. Drive shaft is now 0.27, it looks like. Okay, so check this out, you guys. So you can see, depending on what we deem as the perfect flat surface, it has 2 bumps on the bottom here, so you kind of have to make sure you get her perfect. But it's showing like 1 degree, so we're like 1/2 degree off, I believe. We're like 1/2 degree down because, yeah, so we're like half a degree down, so I think we should be pretty dang close right here. Okay, quick correction, you guys. So I did just remove the tension on those. I should have probably checked those first, but I've removed it, and now there's no tension on it, but look at this. Boom, we are pretty much exact. Hopefully you guys can see the numbers. If I can get a good camera angle on this. Check this out, 1.5, 1.55, so we are now the same as the transmission under full weight. Okay, so I just put half a turn of preload on the Caltrax, so we should be pretty good shape right now. So let me see if I can feel vibration. I'll start her up and check it out. All right, so let's see what we got. Feel it kind of vibrating though. So we just got back from a little late night test run. As far as what I think, we are going on Monday to John's Drivelines. They're gonna check it themselves, all the driveline angles and stuff like that, and I'm sure they'll be able to tweak it or give us a little bit better information. So just before anybody starts going crazy in the comments, why don't you do this, why don't you do that, why blah 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 blah. This is my first time checking driveline angles, so I did it to the best of my ability from my first time ever doing it. We verified it a few different ways, off the crank, off the tail shaft. I even checked it off of the actual case on the transmission, which isn't that accurate, but I just verified that as well. And it seems to be in a much better position, but like I said, we'll get them to double check it. As far as how it's working, it seems better, I would say, but I think it's still there. So take that for what it's worth. We'll see if we can dial it in a little bit better once we get over to them on Monday. See what they have to say, but at least the truck is operational. I'm still fiddling around with some fuel pump configurations. Like I said, I learned that the fuel pump, I think I told you guys in the last one, but I'll just quickly outline it here. The fuel pump system on the Hellcat is very unique. It doesn't have a fuel pressure regulator. How it works is it adjusts the voltage, and essentially it almost works like a fuel injector. It pulses the fuel pump like a fuel injector. So what it does is, it's like I said, it is just a straight hose going from that fuel pump to your rail. There's a sensor on the rail, and it essentially is pulsing your fuel pump, and it is checking to see that the pressure at the rail is where it wants it, and it can actually adjust the pressure at the rail based on if you're beating on it or just driving it around normally or whatever you're doing. So pretty interesting. I didn't know that. I'm starting to get up to speed on that. So very unique to the Hellcats. A regular 392 or a 5.7 Challenger or Charger doesn't have that, but a Hellcat has that system on. So pretty interesting there. So I'm just trying to get a good setup for that. I've kind of messed with it. It's not the final setup, but at least it should start. So if I haven't outlined it, the reason why we're having that starting issue is we had a check valve on our system before, and essentially these fuel rails get really hot on Hellcats, and they're known to boil the fluid in the fuel rails. And if you have a conventional check valve on your fuel system, you will end up over pressurizing inside your fuel rails, and since it's a returnless system, there's nowhere for that pressure to go, and the pressure will go so high that your fuel injectors won't be able to fire. So that's what the issue we were experiencing. So I think I've fixed that issue, so the pressure won't go over high, but I'm trying to dial in my setup a little bit better. So I'll keep you guys posted on that, but at least for now, it seems to be working for us, which is obviously a good sign. So thanks for watching. Any questions, ask down below. If you enjoyed it, give it a thumbs up. See you guys on the next video.